Okay guys, today what we're going to be discussing is complex circuits. And complex circuits are, to me it's a lot of fun. I think y'all will enjoy it. It's not our just kind of straightforward, here's a physics problem, use this equation and answer it. It's you kind of have to think through it. So it'll be Ooh. Alright, so when I say a complex circuit, what I mean, guys, is not every single circuit that we're going to deal with is going to be comprised of just series resistors or just parallel resistors. Okay, I might have a circuit that has some resistors that are in series, some resistors that are in parallel, and some resistors that are just kind of in like limbo, whatever. They're kind of in between. And so we need to be able to figure out what to do with those. And remember, the whole object here is figuring out in the end how much voltage does everything in the circuit get, how much current is going to flow through everything in the circuit. And the reason we need to know that is because certain things can only withstand so much voltage and certain things can only withstand so much current. So we need to be able to evaluate that so that when we build circuits, we're making sure everything's getting the correct amount of current and voltage. So the advantage of a complex circuit is I can have different regions of the circuit that have different properties while using the same battery. Okay, so for example, let's say I'm going to switch here. I'm going to go back to that. Let's say I have a little battery. Maybe it's a little Christmas tree light. Okay, little Christmas tree light, and maybe this light only wants 4 volts. Okay, I mean that's where it kind of is at its optimum performance is 4 volts. And I have maybe it's a bigger light. We'll kind of draw this like one of those. Okay, one of the bigger ones. Okay, maybe this one wants 20 volts. Okay, the problem with the way that we've currently arranged them, if I take those two and I put them in a series, let's say I get a 24 volt battery, because if I'm in a series, 24 volts. And so I put the first one, that'll be the 4 volt bulb that we want. We want it to be 4 volts. Yeah. And this one we want to be 20 volts. So let's say that's a 24 volt battery. Okay, if I put it in a series, the issue that we're going to see is the 4 volt battery is going to tend to have a higher resistance. Okay, the 4 volt, the light that wants 4 volts is going to tend to have a higher resistance. Smaller light bulbs will have higher resistance. Bigger light bulbs, when I say size, I mean like power output, will have smaller resistance. Okay, so when I put these in a series, what's actually going to happen is the opposite. Okay, the small light bulb is going to get a whole bunch of voltage, okay, because it has high resistance, and the big bulb is going to get barely any voltage because it has very low resistance. Okay, so series won't work. So let's say, well, I'll put them in parallel. All right, so I'll put the 20 there and the 4 there. Well, and so now the problem is, okay, well, what voltage of battery do I choose? Because if I choose a 4 volt battery, then that 20 only gets 4. And if I choose a 20, well, then that 4 gets 20. And so you kind of see where we're having an issue here. Okay, so what we're going to end up doing is we'll say, why don't I do a 20 volt battery? And I'll put the 20 volt bulb there. Well, and since these are 4, then let's see, if I do 5 of them, 1, 2, 3, 4, 5. Okay, do you see how this branch now is splitting 20 volts? Okay, so what we're going to get is 4 volts, 4 volts, 4 volts, 4 volts, 4 volts. Okay, so that's what I mean when I say a complex circuit. I'm using the same battery to provide different voltages to different things, however they need it. Cool? Make sense? I know.
Yeah, well, it's in the trash.
There's nothing in there. It's just
There's a bunch of used Kleenexes.
yeah, it's just a whole bunch of used Kleenexes and dirty syringes. So basic complex circuit there. You see, I have one branch that's kind of this parallel thing, and then I have one in a series. Okay. So today what we're going to be looking at is how do I evaluate the resistance. All we're doing is REQ today. We're not going to talk about voltage or current. We'll do all that later. So today just REQ. So to get REQ is 2 steps, and we're just going to repeat the 2 steps over and over and over again. It's really easy. Okay. The 2 steps to get REQ, guys, is the first thing you do is you look through the whole circuit and find anything that is in a series. Okay, so find any series resistors and add them up. Okay, so almost treat it like just a series circuit and get an REQ for just those 2, or just those 3. Okay, when you do that, it's going to create some parallel resistors. Okay, so then you're going to go through and find some parallel resistors. Okay, so combine the series, it's going to create some parallel resistors. Combine the parallel resistors. And when you combine those parallel resistors, guess what it's going to create? Some it's going to create some series resistors. Okay, so then you're just going to go repeat those 2 steps until there's only one resistor left. Okay, so combine the series, it's going to create some parallels. Combine the parallels, it's going to create some series. Combine the series, that'll create some parallels. Combine the, okay, and it's not going to take that many. It's not going to take that many steps for us, but you get the idea. Okay, just to remind you guys, general tips. It's a series if there's no splits between them. In other words, if you follow your finger from the back of one resistor to the front of the other resistor, there better not be anything other than just like an L or a straight. Okay, if there's a T, okay, then that's not a series. So only lines and L's or Z's. A Z's okay. I don't know why we would have a Z. But no, huh?
Just in case.
Or an S.
These are okay also.
No letters where you would have to pick your pencil up. All right, and then parallel. They're parallel if they originate and they end on the same split or on the same conductor. So let me give you an example of that. And this is important because they're not always going to look exactly the same. Okay, so it's important that you know this rule. All right, let's say I have a battery here, a resistor, that's ugly, whatever, and a resistor. Okay, let's look at where we're going to follow the conductor back. This resistor begins here. And guys, you're just going to follow the conductor back either till you get to a split or till you get to another resistor. Okay, so if there were another resistor right here, that we could technically go all the way back to that resistor. Or if you didn't want to, you could go all the way back to the battery. Okay, but the resistor is where you have to stop at a resistor. Okay, you're trying to get back to the battery, you've got to stop at a resistor. Make sense? All right, so this one originates here. I went back. It ends here. Well, so does this one originate there in there. So those are in parallel. Make sense? In the same way that I mean, that looks kind of weird to me, but still, They begin and end at the same point. So those two would be in parallel. Oh, we'll do 2 batteries. Why not? No. Huh? Okay, so let me do a few examples. These are so easy. So easy, but they're fun. Y'all like these. Oh, no. Just one. Go back. There we go. Alright, so this first one, guys, all we're doing is getting REQ.
Nice shot.
All we're doing is getting REQ. We'll work on current and voltage and all that kind of stuff later. I'm just going to copy this down. It's very important, guys, that you have every single step that you do drawn out. Alright, so there's that one. I just drew it out again on paper. I'm going to zoom in some. Alright, so our first step is always to look through and find series resistors. Looking through it, looking at this circuit, do you see any resistors in a series? Which ones? The 9 ohm and the 15 ohm, right? How do you know they're in a series? Not a split between them, right? Okay, so I'm going to transition from this circuit to a circuit where I have an equivalent for those two added. Okay, so I'm going to draw battery. Everything stays exactly the same except for those two resistors. All right, and since they're in a series, they're just going to suck into one resistor. Okay, so essentially when you're drawing your series, if you have two in a series, just get rid of one of them and just draw the other one. Okay, that's our equivalent. Okay, I like to save REQ for the very, very last one, so I'll just call this RA. That's just the way I do it. Okay, RA is going to be 9 plus 15, so 24 ohms. All right, do you see how when I combined these into a series, I created a parallel? Because look, this one starts here and ends here, and so does that one. So I created a parallel when I combined those into a series. Okay, so now I want to get the parallel together. Okay, when we're drawing the parallels together, essentially just cut off one of the branches. Doesn't matter which one, just cut one of them off. Okay? No, you can't cut off right there. That's not a branch, but you could cut off right there. That'd be okay. Make sense? Y'all are lively today. Woo! Okay? So that's parallels. To combine my parallels, I use my equation 1 over REQ is equal to 1 over RA plus 1 over the 6 ohm resistor, right? Okay, so RA is 24 ohms. Okay, so REQ is going to be 1 over 24 plus 1 over 6. So that's going to be 1 over 24 plus 4 over 24, so 5 over 24. So REQ is going to be 24 over 5. And we put that into decimal form, that's going to be 4.8. Okay? What does that equivalent resistance tell me? That's how much the resistance the battery sees in total. Okay, now when the electrons are going to decide where they go once they leave the battery, but the battery is going to provide enough electrons to meet that much resistance of demand. Okay, let's try another one. I'm going to copy this one down while y'all copy it down to Oops. Sorry. We're not all perfect. Alright guys, our first step is to take a look at that and see if we have any series resistors. What's in a series? Alright, everybody say 10, 5, and 8 in a series? Everybody agree? 10, 5, and 8? Everybody agrees that 10, 5, and 8 are in a series. So what y'all are telling me that 10, 5, and 8 are in a series. Okay, so now you're telling me they're not in a series. Okay, there are no series on there. Why not? Because there's a split between 10 and 5, and there's a split between 10 and 8. See that split? See the split? They're not in a series. Okay, so if there are none in a series, what am I going to start with? Parallel. Okay, so I see that 5 and 20 are in parallel. Right? Because they begin and end at the same points. Okay, so 5 and 20 are in parallel, so I'm going to go ahead and combine those. Okay, remember when you're combining, just cut off one branch, and so I'm just going to draw this portion right here. Okay, so that gives me 10 ohm. I'll call that RA again, and 8 ohm. Okay, so here, since these are parallel, 1 over RA is going to be equal to 1 over 20 plus 1 over 5. So it's 1 over 20 plus 4 over 5, so 5 over 20. So that's going to be 20 over 5, so 4. Okay, so RA equals 4 ohms. All right, now look at that. Since I've done parallel, I'll go back to series. You see that those are all in a series now. Okay, so the series sums. And so what this is going to turn into is one equivalent resistance. Okay, and that equivalent resistance is going to be 22 ohms, right? Super. So I'm going to do one more example because this next one's a little bit more difficult, and then I'm going to give you all a couple to try. Okay? Battery's on the wrong side. Whoa. Y'all are... I'm trying to decide, do I need to call the... you know, you could tell I was about to make a joke, huh? We don't want your jokes.
Stop trying to cheer us up. We're just gonna sit here and be awful. Maybe if we had a cake party sometime. Yeah.
Just who do you think you are?
Yo, I'm talking to people all over.
So the next obvious question... okay. That's a little...
Now that we've cheered up.
Alright, so, first thing guys, we go through and we look for series. Do you see any in a series?
Yes.
Which two? 7 and 8, right? Because there's no split between them. Okay, so I just get rid of one of them and redraw it just like it is, just without one of them. Okay, so this is going to turn into...
Can we do it without drawing it every time?
Nope.
Would you like
Really?
multiple things at once?
Nope.
Can we just not work these?
If you're capable.
Guys, I know that this seems easy right now, but when we go back and do current and voltage with it, you are going to be in big trouble if you can't do this. It's going to be much more difficult.
Do we need to draw it?
Do you need to draw it? Yes. 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 Definitely. Okay, so this is going to be RA here. 3 ohms, 9 ohms, 2 ohms, and here RA is going to be 7 plus 8 or 15 ohms. Okay, now this is the point where we say, man, I'm so glad that I drew this out because I can tell what's going on here. Now I want to look for parallel. Do you see any in parallel? The 2, the 9, and the 15. Those are all 3 in parallel, right? Y'all agree? 2, 9, and 15 are all 3 in parallel. All right, so that's going to combine. Just get rid of those 2. It's going to just combine into RA. Yeah, and we're going to call that RB. When I said combine into RA, what I mean is they'll be in the same spot as RA. Yeah. Okay, so 3 ohms, and so 1 over RB. Okay, 1 over RB is going to be equal to 1 over 2 plus 1 over 9 plus 1 over 15. So RB, I don't know what that value is right off the top of my head. I don't know the greatest common denominator of 2, 9, and 15. Something. 61 over 90. Okay, so it's going to be 90 over 61. So let's put that as a decimal. So 1.48. Okay, so RB equals 1.48 ohms. And so that's going to combine into REQ. Okay, those are in a series. They combine together. And so REQ here is going to be 4.48 ohms. Make sense? Easy, right? All right, got a couple for you to practice, and you're just going to have to just write them down. I'm going to give you the answers. Okay, I got the answers. It's not homework. I'm not going to collect it, but I just want to go ahead and give you the answers. And I forgot the answers. I got to work them real quick. I can do it. Okay, the first one is 12.17. What now? I did not. Okay, well, I don't have time to draw out the pictures right now, okay? And the second one is 31.7. Okay, first one 12.17, second one 31.7.